Okay, problem solving, just some tricks. Here's another formula to add to your study notes. People tend to forget this one, so don't forget it. And also this one, okay? Don't forget it. Just going to look at some problem solving techniques, okay? Delegation of 3 people to be chosen from a group of volunteers, 4 lawyers, a minister, 3 retail merchants. In how many ways can this group be formed if at least one retailer must be a member of the delegation? Use both direct and indirect. I want to demonstrate direct and indirect. So we're making a delegation or a committee of 3 people. So in the direct method, you are going, so they want at least 1 retail worker. You could have 1 retail worker, or you could have 2 retail workers, or you could have 3 retail workers. There's 3 cases this way. So out of the retail workers, it's 3, choose 1. And out of the remaining 5, we need 2 more. Or we could have 2 retail workers, and to make a group of 3, we need 5, 1, right? And then out of 3 retail workers, there's 3 to choose from. It's 3, choose 3. We just choose all of them, and it's 5, choose 0. And if you plug that in your calculator, you will get 46 ways. Good? Any questions? Yeah. Yeah, because here it's a group of 3, so the number of people we choose has to add up to 3. So if we have 1 retail worker, we have to choose 2 out of the rest of them. If we have 2 retail workers, we have to choose 1 more. And if we have 3, that makes up our group of 3. We don't need any more people. So let's do indirect. So we'll go total possibilities minus 0 retail, and that will give us at least 1 retailer. Zero. That's my 0. Yes. Okay, so total possibilities is there's 4, 5, 8 people to choose from. 3. Now we're going to add, oh, that should be a minus sign. Now, out of the 3 retailers, we are choosing 0, and out of the remaining, we're going to choose 3. And you get, lo and behold, 46 ways, right? So that indirect involves subtraction. Direct, we're just adding them up.
On the test, will it matter which one we use unless it says which one?
Will it ever say? I don't think it ever says tells you which way. You can do it any way you want.
Yeah, I think on the test you do whatever.
Why do people travel on a bus from the airport to the hotel, but the buses do not use
Okay. All right, so let's look at this bus situation. It can carry 12 outside. So I'm going to just draw a funny little picture here. It doesn't look like a bus, but these represent the 8 people in the bus, inside the bus, and then outside the bus we have room for 12 people. Look, and I'm not an artist, so this is outside. It helps visualize the problem. And this is inside people.
Wait, when you say outside the bus, it's like on the top.
Yeah. Probably on the top.
How are these people traveling outside the bus? This makes sense. Tropical climate. Yeah, double deck. So the top
I know, but I gotta lay out the seats, you see. Okay, good, good. I'm glad. I'm glad we're on the same wavelength.
Diagram helps.
Yeah, it does help. All right. 4 of the passengers refused to travel outside. So we'll put 4 in there. How's that? 5 will not travel inside. Oh my gosh, try to satisfy everybody. It's torture. Right? Okay. So, in how many ways can the passenger be seated if arrangements of passengers inside or outside is not considered? All right. So we just have to worry about who's inside and who's outside. We're not interested in order. So these seats are gone. End of story. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it's something should be 11. 1, 2, 3. Oh, I missed that guy? All right. So why don't we just place 4 inside and the remaining outside? Or you could go 7 outside and you will get the same answer. Because if you remember from Pascal's triangle, 11 choose x is equal to 11 choose 11 minus x. Things on the opposite ends of the triangle are equal.
Oh,
No, it's true for everything. No, because instead of 11, use n. And that's a formula. Like,
Oh, this should be. You don't think this is correct?
if you replace the 11 with an n, it makes more sense. It doesn't only apply to 11. N choose R equals n choose R. N minus R.
How's that?
That is the formula.
Yeah, you like that better? Shh. Oh, a school librarian is purchasing books. Altogether, staff want 3 copies of Webster's Dictionary, 6 copies of the English Writer Styles Manual, 2 copies of Romeo and Juliet, and 1 copy of the History of Mathematics. Because of budget restrictions, he may not be able to buy all of these. Poor Mr. Keogh. If he doesn't buy all of these, teachers are going to be down his neck like nobody. Oh, I shouldn't mention names. It's the intro. I'm just kidding. Yeah. All right. Because of budget restrictions, he may not be able to buy all of these. How many possible purchases could he make? Well, let's take a look. Webster's Dictionary, he could either buy 0 Webster's Dictionary or 1 Webster's Dictionary or 2 of them or 3 of them, right? He has 4 choices. Now, on the English Writer Style Manual, he could pick 0 or 1 or 2 or 3 or 4 or 5 or 6. 7 choices. Now, on the Romeo and Juliet, he could either go 0 or 1 or 2. And on the History of Math, he could either go 0 or 1. So total choices. There's 4 choices on the Webster's Dictionary. There's 7 choices on the manual. There's 3 choices on Romeo and Juliet. And there's 2 choices on that. We subtract 1 to make sure he makes 2, ensure he makes at least 1 choice. Because it's a purchase. How many purchases could he make? If he doesn't buy one book, then there's no purchase. Oh, this.
Ah,
Yeah.
What if the quota is so restrictive that you can't afford
That's okay if he buys all the books. That's he may not, but it's possible he could. But that's a thank you for thinking of that.
so if the question said he can't buy all the books, that's the question.
Yeah, then you subtract 2. He has to make at least one purchase, but he can't buy all of them. Then you would subtract 2. Absolutely. So the formula for that is total number of selections from P items of one kind, Q items of another, R of another is this. P plus, notice it's 3 plus 1, 6 plus 1, etc. minus 1. 1 is subtracted to ensure one selection is made. A set with n elements has 2 to the n subsets. Okay, find the number of subsets. Oh, this I think we ran into this already, right? Because if you have a set with 5 elements, A, B, C, D, E, you could either pick. You could pick 0 A's or 1 A, 0 B's or 1 B, 0 B C's or 1 C, 0 D's or 1 D, 0 E's or 1 D. But an empty set is a set of itself, so we don't have to worry about subtracting 1. So it is 2, 4, 8, 16, 32. Or 2 to the exponent 5 equals 32.
I did. I figured so.
You have to, wait, you have 2 choices on it. You could either take, let's say you have 5 elements, so I called them A, B, C, D, and A. So you could take 0 A's or 1 A, 0 B's or 1 B, 0 C's or 1. So there's 2 choices on each. No problem. In her pocket, Patty wants to throw coins in the fountain at the mall. Ho, ho, ho. This is in the olden days when we had pennies.
those days.
A nickel is 5 cents. So we want, how many different sums of money could she throw into the fountain? Okay, if we want at least one sum, we're going to have to add 1. So you're going to go 0 choice is 1, 0 choice is 1. You don't take a dime, you do take a dime. You'd have a choice. You take a quarter, you don't take a quarter. So you have 2 times 2 times 2 times 2 minus 1. That is equal to 15 different sums.
It's not asking you for the value of the sum, so that doesn't matter.
No.
What happens if it asks you for a value of the sum?
Then you start figuring that out.
Okay.
Do you want the values?
No, please no.
Huh? And we subtract 1.
Choose through it. She has to throw something. Choose through it. She should use her money to buy something. She's at the mall.
Okay. How many different sums of money could she throw if she had 3 more pennies?
3 more.
So you said 2 to the power of 7 and minus 1.
What?
Is it 4 times 2 to the power of 3 minus 1?
Well, if she has 4 pennies, how many choices on the pennies?
5?
It becomes 39.
You're right, it is 39. 10 times, okay.
But if it was, she had 4 more pennies, then that would be different. Because
Then you have a nickel.
you have a nickel, 5 and 5 cents.
You have to, yeah, you have to be careful
Do
about,
we have to deal with questions like that for the test?
no.
That's more complex.
No, you have to subtract the double counting. There is an example in your review. In your review, there's a really good example on what they subtracted. I think it is. Look at all the review you have. It's here. Page 70. It's page 70, this question. Because 2 kilograms adds up to 16. So I'll let you worry about that later. Okay, let's find the divisors of 100. Oh. Fine. How's that? Okay, first you need the prime factors. So the prime factors are 2 times 2 times 5 times 5. Agreed? I feel tired today. Okay. We could pick 0 2s, 1 2, or 2 2s. We could pick 0 5s, 1 5, or 2 5s. So we could go 3 times 3 equals 9. There are 9 divisors, including 1. No, because we're including 1 as a divisor. So that we could subtract this, but we add.
Add one back because. So like if you showed all of those steps, you'd have to minus and plus 1. But because the net result is 0, you don't have to show it.
Here are the divisors, just to prove to you. 1 2 4 5. So there's 9 divisors.
What about 10? Oh, yeah, 10's there. But 10 times 10, oh, okay. It's a perfect square. If it's not a perfect square, there would be an even number of divisors.
Right. I'm not sure. I never looked at it.
Because 100, 10 is repeated, right? 10 times 10 is 100. But if it's not a perfect square, then a divisor can't be repeated, right? Does that make sense? So it will have a even number, I think.
Could you ask me that question when I'm more awake?
I'll come after you're done.
Okay. How many dance committees of 5 students can be chosen in a school with 1,000 students? Shh. Are we good on this one? Do we still have questions? Yep. Because the prime factors make all the divisors. We use the prime factors to so let's say I pick 0 2s and 1 2. 2 is a divisor. What if I pick 1 2 and 1 5? 2 times 5 is 10 is a divisor. I use the prime numbers to calculate all my divisor. How many? Okay. One particular student must be on the committee. So Bob Smith must be on the committee. We got him. How many students to choose from?
4.
Oh.
Wait, 9,999.
999. And that is
4.125145625 times 10 to the 10.
awesome.
Wonderful.
You could do one thing right.
Hey, I did it wrong. Because I said 9999 instead of 999.
How many dance committees of 5 students can be chosen if we can't use Bob?
Easy. 8.2. It's 8.2.
Well, we can't use Bob, so we're down to 999.
Choose 5.
That equals. I think that's a 2.
Yeah. And then it's 10 to 12.
Yeah, this is very approximate, right? Because we've lost a lot of decimal. Ah, I like this one. How many permutations of the numbers 1 to 9 taken 7 at a time include 1, 2, 3?
1, 2, and 3, all 3 of them?
What do you mean taking 7 at a time?
Of the 9 digits.
Actually 10. Oh wait, no, 9. I thought it was 0.
Are we good? We're picking these 3. We're assuming no repetition. So we've got those 3, but we're taking 7 at a time. So we need 4 more numbers, right? So out of the remaining 1, 2, 3, 4, 5, 6, we're choosing 4 more. But it's permutations. So we choose first, and now we're going to arrange those guys. Do you get it? We choose first, and then we're going to arrange.
What if it's like 1, 2, 3 together? What just makes it?
Oh, together?
Like 1, 2, and 3 must be beside each other. Like they must
So if that was the case, you would go, well, arranging 1, 2, 3, 4, 5, 6, 7 things. So it's 3 factorial, 7 factorial instead of.
It would be 3 factorial 4.
1, 2, 3, 4, 5, 6, 7.
No, 3, because you're still using 7.
Oh yeah, my bad. So 1, 2, 3, 4. It would be 1, 2. There'd be 1, 2, 3, 4, 5 factorial times 3 factorial. Good. Yes.
By include 1, 2, 3, does it include 1 or 2 or
1, 2, and all
1 and 2?
There should be an and in there.
It should be an or, right?
We want all 3. We want 1 and 2 and 3.
Oh, I see. Okay.
Or means either or.
What if it's 4?
If it's or, it's
Are we gonna go there?
No. I'm trying to get the idea you choose first and arrange later. Sure. What we want to do is we're choosing 7 out of 9 numbers. So we're going to choose first. They told us we have to have 1, 2, and 3. So out of those 3, this should be 3, right? This should be out of the 3 we chose 3. Is that better?
There we go.
There we go. My bad.
So the 3, choose 3 ensures all 3 are chosen.
Yeah.
just 1.
So if it was or, then
It should be 3 choose 1. Yeah. And it should be 4 choose, I don't know, no, it's 5. 6 choose 4. 6 choose 4 is right, yeah, that's right.
Are we good now? Well, we need 7 numbers. We have 3, so we have to choose.
Sorry, never mind. They're 9. Sorry. I thought there's 7.
No problem. Are we good? Question? Oh, we chose them. Now we have our 7 numbers. Like we chose 3 numbers and 4 numbers. We chose them, but we have to now arrange them. Yeah. Because a permutation means arrangement.